Most multi-agent AI systems operate like rigid clockwork, working well under controlled conditions, but they fracture the moment they encounter a shifting environment. Traditional software is fundamentally static. Because it only executes predefined programming, it lacks any internal mechanism to observe its surroundings or learn from its own mistakes. The generic seed is a living, multi-agent operating system. It ships inside a Docker container, an isolated code package awaiting new environment data. As it expands, you see its internal anatomy, a pre-built 7-layer architecture, complete with specialized agents, memory stores, and governance protocols. The seed provides the foundational DNA for a custom business unit. Instead of an out-of-the-box solution, it offers a framework that develops its own capabilities based on the specific work it performs. Activating this architecture requires a human operator serving as the system's gardener. Their role is to provide the operational soil the seed needs to grow. As shown on the left, the gardener injects their expertise through a single configuration file called a niche-config.yaml. YAML is a human-readable language used to define settings. In this case, the business mission, vertical, and specific tool integrations. Within hours of reading that file, the architecture boots up. Base agents, like planners and executors, begin to tackle the specific domain the gardener defined. While the terrarium is now active, it is currently raw and unrefined. To become commercially viable, the system must learn how to navigate the complex edge cases of its specific environment. A core doctrine drives this ecosystem. Agents learn exclusively from human decisions made on real-world exceptions. The operator directs this learning through ADINA risk tiers. This governance framework acts as the heavy shears the gardener uses to prune away unverified or high-risk actions. Routine tasks hit the green zone and execute autonomously, driving operational growth. High-risk actions trigger the red zone, where governance blocks the path entirely. The yellow zone handles edge cases, pausing execution and escalating unfamiliar scenarios to a human steward for final judgment. Every yellow zone escalation serves as the highest value learning signal in the entire system. It marks the exact moment where human judgment is captured and converted into data. When the human resolves a yellow zone pause, their manual decision is recorded in a structured database called the exception library. This schematic shows an exception record's anatomy. It pairs the agent's failure context with the human's corrective rationale, creating a structured, reusable pattern. Every single night, the system's self-improvement engine runs automated batch jobs to scan this library for recurring failures. Once an error pattern repeats 3 times, the engine extracts the human logic and automatically rewrites the agent's core system prompt. This process allows the system to restructure its own operational DNA. It learns exactly where not to grow, based on the boundaries the human has established. Each isolated terrarium is actually part of a global ecosystem. Thousands of specialized seed instances operate in parallel, each learning from its own local environment. These instances are linked through the upstream contribution protocol. This protocol allows individual businesses to opt into a collective network where they trade local discoveries for global updates. When an instance discovers a solution, it uploads the logic to a central hub. The system strips away private data, leaving only the generalized pattern. The hub then distributes it to all instances. A Tokyo legal agent's discovery instantly upgrades a London logistics agent. This network effect ensures that every single deployment makes the foundational seed smarter for everyone else. This architecture redefines the operator as an ecosystem engineer. Instead of building static tools, they are cultivating a growing, adaptive and manual governance. Human stewards transform their individual corrections into a shared, growing infrastructure of intelligence.